Today, we're stepping things up for our Christmas display. Way up. If you haven't seen the first couple of videos in this series, I'd highly recommend checking them out first. It'll provide some good context to what we're working on here, but in short, lots of lights, Christmas cheer, good times. The big feature we wanted to add in our show for 2025 is what's known as a mega tree. You can probably figure out what that means from the somewhat unoriginal name. In essence, we want to add a massive version of our mini trees to add a little height and, most importantly, wow factor to the show. You might assume that this would be as simple as scaling up our mini tree design, and you'd be mostly correct, but there are some key differences I needed to address. Most commercial solutions for a mega tree have steel toppers with strapping for each string. Each strap has bullet pixels pushed into little holes along its length. These are heavy, bulky, and very difficult to store, so I'm going to use some of the same seed pixels as the rest of our display so we don't have to deal with that. Our mini trees use 14 strings with 27 pixels per string. For the mega tree, we wanted to go a lot bigger. But how much bigger? I built a rough 3D model of my parents' front yard last year to help with planning and programming the show. So I loaded it up and started playing with different tree heights and diameters until I found something that looked good. Where I landed was about 4 meters tall with a 2.3 meter base. This would make it just a little taller than the house when viewed from the front and keep the driveway usable while the Christmas display is running. Obviously, the taller we make our tree, the wider the base becomes, and as the base gets wider, the strings of lights get further apart. So we'd need a lot more pixel strings than our mini trees to make it look good. I loaded the dimensions into a great mega tree calculator on lightshowhub.com and started playing with string counts and pixel density. What I ultimately landed on was a 270-degree tree, no need to have lights on the back, with 40 individual strings of 1 inch or 25mm spaced pixels. All up, the tree could contain just shy of 7,000 individually addressable pixels. This calculator also let me calculate the power required for the entire tree. In my case, I'll need about 900 watts of power to drive the whole thing. I'll also require quite a few pixel ports to manage this tree. The controllers I'm using can drive 800 pixels per port, so we'll need to split it up over a bunch of ports. I'll show you a bit about the controller in the installation video a little closer to Christmas. For now, we need to get our tree built. First, I had to figure out how to build a 4-meter tall tower without breaking the bank and figure out some way to store it. I hunted around for a while and I came across winch-up speaker stands. These stands are designed for holding front of house speakers or truss at a concert or show. They're very sturdy, relatively affordable, and a local sound and lighting store had one in stock. The one I landed on has 2 stages, or 3 depending on how you think about it, and can be wound all the way up to just shy of 4 meters. It comes with this folding tripod base and is rated to 85 kilograms of load. Way more than we need, but if there's one thing you can count on me for, it's overkill. The stand is super sturdy, but I still wanted to add some guy wires in case of high winds. I wasn't confident in a 3D printed solution, so I decided to use the sponsor of this project, PCBWay, to get myself a machined aluminium part. PCBWay offers a complete array of manufacturing services for your projects or for manufacturing of finished products. I put together the design as I would do anything else, then I printed it in PLA to check the fitment of the part and ensure I was happy with the design. This slides over the 3rd stage and clamps around the post. There are 3 little eyes we can attach guy wires to that will be held in tension to stop the tower from being blown over. Then I took that very same file I printed and uploaded it to PCBWay's online quoting tool. This is the first machine part I've ordered from PCBWay, and I was pleasantly surprised at how easy the whole process was. I uploaded my file, selected my material, in this case 5052 aluminium, then I selected the milled surface finish. They can tap holes for you, test fitment, and machine to incredibly high tolerances on request. Once I'd made my selections, I hit submit, and then one of PCBWay's engineers reviewed my files. I placed my order, and about a week later, my parts arrived. The final parts are fantastic and should do a great job of keeping our tree upright even in poor weather. If you have a project that's beyond your home workshop's capabilities, check out PCBWay's machining and printing services. It's a great way to expand the possibilities for your own projects. Thanks again to PCBWay for sponsoring this project. I'm putting the tree together at my place well in advance. I want to test everything and make sure it's all working before taking it to my folks' place nearly 50 k's down the road. So while I'm testing, I'm using the included tripod stand, but the front yard of my folks' place is sloped up from the front, and we need to make sure nothing will move around or tip over. So I'll need a different solution for the base of the tree. Fortunately, the tripod can be removed easily, so I've come up with a 3D printed solution for this that I'm pretty proud of. Get subscribed so you don't miss our installation video where I show that off. Our new mini trees use a PCB from PCBWay at the top and bottom of each tree, making it super easy to attach our strings of LEDs to the top and bottom. Unfortunately, PCBWay can't manufacture a 2300mm circular PCB. So we needed another solution for the base of the mega tree. We can still use a PCB for the topper, so I designed a topper with 40 string attachment points instead of 14 to go on top of this tree. It's really just a much larger version of the mini tree topper with some changes for running multiple power supplies. But for the bottom, we had to go a different route. The base of the tree will be made of a spoked wheel made out of PVC conduit and plumbing pipe. I designed some multi-part 3D prints that would hold the spoked wheel shape and allow the whole thing to break down for storage. This was a bit of a slog to print with a total of about 100 print hours, but my Prusa Core ones flew through it with no issue at all. These are made of ASA, so they last well in the sun, and because ASA is a pretty tough material which we're gonna need. This hub makes up the center of our wheel, and these pieces are all identical. They're screwed together with some M4 fasteners and slid over the bottom of the stand. I'm using PVC pipe for the spokes, and they're glued into the hub. This doesn't need to be super strong, but we do need enough strength to cope with the tension from the LED string, so hopefully this does the job. I still want to avoid having to make hundreds of wire-to-wire connections, so I made these little H-shaped PCBs as well. These each have solder points for the pixel string, as well as an attachment point for a pigtail. I also added these 12mm holes for our tensioning solution. In Australia, we sometimes call these Oki straps. I believe it's because they were once called octopus straps, and our nation has a strange obsession with shortening everything to as few syllables as we can manage. Each one of these little PCBs will be fixed to the pixel string on one end, and the Oki strap will be looped around the PVC wheel and hooked onto the hole, holding it taut. In theory, this should let us keep gentle tension on the pixel strings at all times, keeping the tree looking nice and neat. And we can use the crank up stand to adjust the tension when needed. With that all sorted, I got to work assembling the tree. I started by cutting all my strings to length carefully. Miscounting would have been a disaster, so I took my time with this one. Thanks for your help, Britt. Once I had all 40 strings ready, I soldered pigtails onto the bottom PCBs and then soldered on the pre-cut strings. These PCBs have the same features as the topper that help make sure the tension is on the string itself rather than the solder joints. You might be wondering why these little boards are this shape. Well, one of the biggest practical issues with light shows like this is just the storage of all the props in the off-season. These little boards are designed to help with this problem. When it comes time to pack up for the year, you can wrap your pixel strings around these little PCBs and store them away in a bag ready for next year, hopefully preventing too many tangles and making it worlds easier to reassemble your show next year. Quick side note, if you want to build one of these trees yourself, I've listed the PCBs for pre-order on the site, and there's a tutorial on the saucepan for assembling one yourself. You'll need to handle the structure of your tree, but all the prints I've used today are on printables as well if you'd like to replicate this exactly. Once the strings each had one of these H-shaped PCBs attached, I soldered the other end of each one to the topper PCB. As I soldered each string, I checked it was correct with a multimeter and tested them before moving on to the next one. The last step is to waterproof all the connections with some liquid electrical tape. And that's all the electrical connections made. Now we just need to set up the tree itself. First, I put together my tree's base with the 3D printed hub and the PVC spokes and conduit. As I said before, these are all printed in Prussiament ASA. ASA is UV stable and very strong, and it should last really well in the summer heat. I've used Prussiament for this whole project mainly because it's the most consistent and reliable filament I've used, and I want these parts to last. All these parts bolt together to form our spoked base for the tree, and then the PVC conduit is zip tied to these prints to form our wheel or our base. Then, using a 3D printed part to adapt the topper PCB onto the stand, I slid the topper on and tightened it down with the grub screws. Then, working around the tree, I unfurled each string and attached it to the base with my Oki straps. After carefully laying out the strings to try and avoid tangling, I cranked it up. This was a big moment. This tree has been a long time coming and will form the centerpiece of the display for years to come. So to say I was excited is a bit of an understatement. I put some light tension on all the strings and the rubber strap tensioning system seems to be working well. Next, I connected the tree to its temporary controller. I'm building a new one specifically for this tree a little later on in the series, but I'm using last year's controller for testing. With some configuration done in X-Lights and Falcon Player, I switched it on for the very first time. This is one of those projects where the scale is really difficult to comprehend when it's all in pieces. The complete tree is seriously huge, and with it turned right up, it's incredibly bright. Definitely too bright. I spent some time playing with the tree and testing some effects on it, and I'm very excited to roll this into the sequences for this year's show. If you want to see how we end up using this and the installation of this mega tree and the rest of the light show, make sure to get subscribed so you don't miss out on the next video. Speaking of which, if you're in the Melbourne area and you'd like to join us for the opening night of this year's light display on the 29th of November, head to the link in the video description to find the details. There'll be a casual free sausage sizzle at the park across the road before the show kicks off in the evening. Everyone is welcome, young and old, so if you can make it, I'd love to see you there. And thanks to the guys at Prusa, we'll be giving away a Prusa Mark IV's to whoever finds me and tells me about an awesome project they'd use the printer for. I'll pick my favorite and you can take home your brand new printer. I'll also have a couple of runner-up prizes and Stockpot project kits to give away, so make sure to come say hi. If you can't make it, the show will be running all the way to the new year, so you'll be able to check it out anytime. The next video will cover setting the show up, including installing the mini trees, a little bit of programming the show, and some more information about our controllers and the brains that run the whole thing. If you don't want to miss that, get subscribed and keep an eye out for the next couple weeks. If you like this video, leave it a like. If not, let me know why. Thanks a bunch for watching. I'll catch you next time.